Today we're going to be going over AP Stat Chapter 18. This is the introductory chapter into the concept of sample proportions and sample means. A sampling distribution is when you take a sample drawn from your population and you collect statistics on that sample. Now, we a lot of times don't have information about the whole population and we're trying to estimate that, and when we do that, we estimate or infer information about the whole population. It's called a sample proportion or sample mean, and we're doing statistical inference. The relationship between the sample and the population is distributed on the normal model using the sampling distribution for all samples taking of that statistic. For the sample proportion, we look at the mean and the standard deviation. Sample proportion means that we are concerned with a percentage amount of the population. The mean will be P, which stands for the percentage that we're given in the situation. Standard deviation is the square root of PQ over N. Now, P will be the percentage that you're given in the situation. Q is the opposite percentage, meaning everyone else up to 100%. And N is your sample size. For our first example, based on a past experience, a bank believes that 7% of the people who receive loans will not make payments on time. The bank has recently approved 200 loans. What are the mean and standard deviation for the proportion of clients in this group who will not make timely payments? We're going to draw the normal model. We're going to label up to 3 standard deviations, just like we did back when we initially studied the normal model in Chapter 6. And we're going to find the probability that over 10% of these clients will not make timely payments. Starting with the mean and the standard deviation. The mean we know is 7%. That's the percentage we're given in the situation. Standard deviation formula is the square root of PQ over N. That's the square root of 7% times 93% over 200. And when you type that in your calculator, you get 1.8%. Now your calculator is going to start a parentheses at the beginning of the square root, and you just need to close it at the end. You don't need to use any other parentheses throughout the square root. A lot of times people will ask me where I got 93%. If you think about 7% subtracted from 100%, that leaves 93% left over for everyone else. So 93% of the people are making their payments on time, and 7% are not in this situation. Okay, so the mean is 7%, that goes in the middle. If we go out one standard deviation, we're adding and subtracting 1.8% off of that mean. So that gets us 5.2% on the low end and 8.8% on the high end. And if you remember the rules of the normal model, we have captured 68% of the data when we go out one standard deviation. If we add and subtract 1.8% again, then we get 3.4% on the low end and 10.6% on the high end. And the rule about 2 standard deviations is 95% of the data is captured within 2 standard deviations. If we go out another standard deviation again, we're adding and subtracting the standard deviation one more time. We get 1.6% on the low end, 12.4% on the high end, and 99.7% of our data will be captured in this interval of numbers. Now we're going to find the probability that over 10% of the people are not making timely payments. To do this, we find a z-score. The z-score is x minus the mean over the standard deviation. Here our x is 10%, minus the mean, which is 7%, over the standard deviation, which is 1.8%. That gives us a z-score of 1.667. You have to subtract, hit enter, and divide in a second step. You can't do it all in one step. You'll get the wrong answer. We want to be over that percentage, so we're going to do normal CDF of 1.667, comma 99, meaning we're going everything above that, and that gets us 4.8%. So there's a 4.8% chance that over 10% of the clients will not be making timely payments. Okay, example 2. Public health statistics indicate that 26.4% of American adults smoke cigarettes. Using the normal model, I want you to draw the sampling distribution for a randomly selected group of 50 adults and label your model up to 3 standard deviations. And then I want you to find the probability that over 33% of this group will smoke. So pause the video until you're ready to go through this. Okay, start with the mean and the standard deviation. The mean is 26.4% because that's the percentage we're given in the problem. Standard deviation is the square root of PQ over N. which is the square root of 26.4% times 73.6% over 50. And when you do that square root, you get 6.2% for the standard deviation. Again, that Q value, 73.6%, is everyone else up to 100%. We started with 26.4, so everyone else would be 73.6%. Okay? Or in other words, think about it as that's the percentage of people that are not smoking. Alright, let's draw a normal model. The mean of 26.4% goes in the middle. We're going to add and subtract the standard deviation once from the mean. That gets us to 20.2% on the low end and 32.6% on the high end. The normal model rules tell us that 68% of the data are captured in that first standard deviation. If we go out a second standard deviation, we're down to 14% and up to 38.2%. Or 38.8%, excuse me, and we have captured 95% of the data in that interval. And if we go out one standard deviation again, we get 7.8% and 45% as the interval of numbers for that last standard deviation, and we have captured 99.7% of the data in that interval. Okay, let's find the probability that over 33% of the people are smoking. So we're going to find our z-score, x minus the mean divided by standard deviation. 33% is our x, minus 26.4% is our mean, divided by 6.2% is our standard deviation. That gives us a z-score of 1.0645, and we want to be above this percentage. So normal CDF from 1.0645, comma 99, and that gets us 14.4%. So what this is telling us is we have a 14.4% chance of over 33% smoking. Conditions and assumptions. For the sample proportion, there are 4 conditions that you need to check before you can use the normal model for a sample proportion. The conditions are that your sample should be an independent and random sample. Independent means that one person or one event is not influencing another one. And that last problem we just did about smoking, that means one person's decision to smoke is not influenced by another person, meaning that there's no peer pressure. We make that assumption. A random sample means that we've collected it randomly and that there's no bias in our sample. The population has to be at least 10 times the sample size. Here that means that our sample of 50 people, 10 times that would be 500, and that means that there has to be at least 500 people in the United States, which there are. You have to have at least 10 successes and 10 failures in your sample. That means that we have to have at least 10 people that smoke and 10 people that don't smoke in our sample, and we met that condition as well. On the AP test, you will be expected to list out these conditions and explain how they are met in your problem. Okay, let's move on to the sample mean. The mean is the average amount that you're given in the situation, and the standard deviation this time is the is the standard deviation divided by the square root of n. The standard deviation that you're given in the problem relates to your population, and you're going to use this standard deviation that you're given to find the specific standard deviation for your sample size. Okay, so it's a little bit confusing because you're given a standard deviation, but you have to find a different one. The one that you have to find relates to your sample. Okay, here's our example. Assume that the distribution of human pregnancies can be described by a normal model with a mean of 266 days and a standard deviation of 16 days. We're going to draw the normal model for this distribution of mean length of the pregnancies among the sample of 60 pregnant women at a certain obstetrician's office. We're going to label the picture up to 3 standard deviation and then find the probability that the mean duration of pregnancies will be less than 260 days. This is a sample mean problem because they talk about a mean amount of the population. In a sample proportion, you're talking about a percentage amount of the population. That's how you can tell the difference between the two. If they give you a percentage amount, you're talking about a sample proportion. If they give you a mean amount, you're doing a sample mean. The mean is 266 days. The standard deviation formula is to take the standard deviation for the population, which is 16, divide it by the square root of n, which means divide by the square root of 60 in this problem. That gives us a standard deviation of 2.07 for this sample. Now, putting the mean of 266 days in the middle of our normal model, we add and subtract the standard deviation one time. That gets us 263.93 days on the low end and 268.07 days on the high end. We've captured 68% of our data in that interval. If we go out a second standard deviation, we are at 261.86 days on the low end and 270.14 days on the high end. We've captured 95% of our data in that interval. Going out one more standard deviation, we are at 259.79 days on the low end and 279.21 days on the high end. We've captured 99.7% of the data in that interval. Now we're going to find the probability that our mean for our sample is less than 260 days. To find the z-score, we do x minus the mean divided by the standard deviation. That's 260 minus 266 divided by 2.07. That gives us a z-score of negative 2.899. We want to be less than that for our mean. So we're going to do normal CDF from negative 99 to negative 2.899. That is about 0.19%, so a very low percentage of chance that our mean would be less than 260 days. The conditions for sample mean are very similar to the conditions for sample proportion. There is one difference though. The independent and random sample is still the same for both the sample proportion and the sample mean. Independence means that one event is not influencing another one. Here with the pregnancies, that means that one person getting pregnant is not influenced by another person getting pregnant. There's no peer pressure to get pregnant because your best friend is. The random sample means that your sample was collected randomly and there's no bias in the way that you collected the data. The population has to be at least 10 times the sample size. That's the same condition as it was for sample proportions. Here we had a sample of 60, so we need a population of at least 600 pregnant women, which I'm sure there are at least 600 pregnant women in the United States. The sample size should be large, more than about 40, and we had a sample of 60, so that condition has been met. Put a star in that last condition because that's the one that's different for sample means than it is for sample proportions. In a sample proportion, you have to have at least 10 successes and 10 failures in your sample. In this sample mean condition, we have to have at least 40 in our sample size, meaning it has to be big enough.